So here in number 7 we read that we have a triangle that has the same area as a rhombus. So let's draw these two things. Sure, why not? So here I have a triangle, and the amount of space that that triangle takes up is the exact same amount of space as this rhombus. Okay, made out of the same piece of paper. The diagonals of the rhombus are 3 units and 8 units. So these areas are the same. Let's see, what do we know about this over here? We know we have a side of 12 and a side of 16. So, all right, let's do some stuff here. Let's make our math, do some math. We know that the area over here is 1/2 of 8 times 3. 1/2 of 8 times 3 is 12. So 12 is the area of this triangle, and we want to know what the measure of the angle here is. Okay, so there's a formula that we can use that when we know two sides of a triangle and the angle in between them. And that's the formula for the area of a triangle if we know two sides and the angle in between them. Well, we know the area is 12. We know this side and this side are 12 and 16. So we can solve this equation for C and figure out what the angle is. So let's go back and do the rest of our math here. 1/2 of 12 times 16 times the sine of angle C. So I have lots of things that I can multiply together. 1/2 times 12 times 16 is 96 times the sine of C. So I can divide both sides by 96, solving this equation for angle C. Sine of C equals 12 divided by 96 is 0.125. And then the last step is to get rid of the sine. And we get rid of sine by taking its inverse. So we do this inverse trig operation to both sides. Okay, inverse of sine cancels out, and we get C once again. So this is the measure of angle C. And over here, when I type this into my calculator, the inverse sine of 0.125 is 7.18 degrees. And that's the measure of this angle in between our sides of 12 and 16.